Chapter 7 review. You better, you know, savor this like a fine wine. This is the last time you'll hear my voice. Maybe till the exam, I suppose, but um, this is our last video, so let's get at it. In geometry, there was a lot of review, but this business, I mean, even though this was review, these were hard questions. These make great, great thinking questions, these ones. And then we did some stuff that was brand new. All that circle stuff was brand new in there as well. So this is one of these sort of typical hard surface area volume questions. And often we'll have a cost component involved, or how many of these can you get out a certain amount of material or whatever, but not this one. This one's actually pretty straightforward. So the volume, I'm going to do kind of a shortcut here. I'm going to do the volume is the area of the base times the height, right? But the area of the base happens to be a strange shape. It's kind of looks like this, right? And a circle on top. That's not very good, but you get the idea. It's this chunk here, 20 across the bottom, 30 high. That's 30 here. And we don't know about the circle, right? So, well, if that's 20, notice then, what's the radius of the circle? The radius is 10. So if that's 10, how much is this? This is 20. This is actually a square, supposed to be. The base is 20 squared plus half a circle. Pi times the radius, which is 10 squared, divided by 2. 400 plus, that's 157. 557, and then the height's 36, easy peasy. The volume's no problem at all. Well, except for my pens. I think my smartboard pen is running out somehow. It's because of all these videos I've made for you folks. That's why it's running out. Right now I've lost my place. Where am I? Okay, right there. 20,052, roughly, centimeters cubed. Remember, each centimeter cubed is a milliliter, and so this is actually about 20 liters, a 20-liter mailbox. Although hopefully we're not filling it with water, right? The surface area is, notice it's two bases. Area of the bases. The two sides, you know, like this piece here and the one on the other side are the same. And then the area of the bottom, plus the area of the curved part, right? This curved part is a half a cylinder. All right, so we got the two areas of the base. You notice we got the base over there, 557. And as it turns out, because the bottom's actually, this is 20, and this is 20, and this is, there's actually three. These three pieces that make up kind of the square parts of the mailbox are all the same. So these are actually three that are 20 by 36. The curved part, notice that we've already counted this circle part in our base, so I just need to do the curved part, which is pi d, the diameter, which is 20, right? The diameter is 20 times the height, which is 36, but then divide by 2 because I only need half a cylinder, and I get about 4,405 centimeters squared. Okay, and then example 2. a circle has, this is back onto the circle stuff, and there's some good questions that we can ask here. I think there's one like this in the homework. It might have been exactly like this one that we met during the regular season of the course. The circle has a radius of 10 centimeters, as it's shown. The length of the chord AB is 8. Determine the measure of ACB. So this is what we want to find here. Notice that this is an inscribed angle subtended by the same arc as this central angle. What I do know is that central angle is twice angle C, right? Oops, let me write that a different way using legible English here. So angle C, which is what we want, ACB, angle C, that's half of that central angle, angle O. I'm going to call that theta just so I don't have to write my angle sign all the time. So angle theta. Well, angle theta, notice, is in a triangle, right? It's a triangle where I've got the three sides. That's 10, that's 10, that's 8. So I'm going to use the cosine law. Some more good trig review here. 10 squared plus 10 squared minus 8 squared all over 2 times 10 times 10 is 136 over 200. And got to do the inverse cos of that. I'm not worried about ambiguous case or anything like that. That was only for the sine law. I had to worry about that. This works out to be 0.68. And I get that angle is 47 degrees. And so the inscribed angle is half as much. Angle C is 47 divided by 2 is 23.5. Not bad. A couple of nice points there. Some trig involved. Beauty. And this is another great question. Good thinking question. Sammy designed a garden as shown from point to blah, 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 blah. And hopefully you can read that okay. And hopefully you can read that okay. That says 12. The radius is 5. And so what do we got here? Well, I see basically three pieces. Two of them are the same. This piece and this piece are triangles. And you see it here? That could be the height. This is the base. And I can calculate the area of that. That's no problem at all. The problem is this shaded part is actually a sector, isn't it? It's a big sector, but it is a sector. So here, the total area is going to be the two triangles plus the area of that sector. And so I'm going to do my final answer here and my rough work over there. So area of the triangle, this one's going to be easy, right? Because for a triangle, all I need to do is have the base and the height at a 90 degree to each other. Base is 5, height's 12, divided by 2 is 60, 30 square feet, right? And then there's those two triangles. How do I find this sector? I know it's a fraction of the area of the triangle, right? Or area of the circle, rather. This piece here. I need to know this angle. I'm going to call that angle theta, or not theta, because that's theta. I'm going to call it alpha. And how do I get alpha? Is I'm going to go 360 subtract the thetas. The thetas, well, I've got to figure out what theta is. How do I figure out what theta is? Well, it's the opposite over the adjacent. It's tan. Opposite over adjacent, and I can do the inverse tan of that, which is about 67.4 degrees. So it means this entire angle is twice that, and the other angle, the angle that I want to find so I can calculate the area of the sector, is going to be 360 minus the two thetas, which is around 225 altogether. And so then the area of the sector, running out of space here, get rid of that, The area of the sector is that fraction of the circle. And it's not an arc length, so it's not the perimeter, it's the area. 5 squared. Jam that all into a calculator, and you get about 49. And so this is 49. And then this makes a total of 109 square feet. Great question. Involves trig, involves area, involves our stuff on circles. Great thinking question. Any thinking questions involve more than, good thinking questions involve more than one topic in a question. That's it. That's MCT4C. Good luck on your exam, folks. I'll see you soon.